Hi, I'm Robin, Application Engineer at Materialise, and today I will show you how to easily create a 3D model of a patient's airways on a CT scan using Materialise Mimics InPrint. The first step of this workflow is the creation of the region of interest, or ROI, which will display the airflow inside the airways. Then, we will show you how you can edit and refine the ROI you have created. When the region of interest is correctly defined, we will create a hollow 3D part based on the ROI. After editing the part, we will finalize the model by placing a label on it and making the model ready for printing. To define the region containing the airways, open the thresholding tool. Inside the thresholding tool, you can define a threshold containing all the voxels within a certain interval of gray values. The gray value is proportional to the density of the tissue, and the tool allows you to select all the structures within a certain range of density, expressed in Hounsfield units. The software includes several predefined thresholds corresponding to certain tissues. Open the Preset menu and select the Airways preset. On the 2D viewports as well as on the 3D preview, you can see that the airways are displayed in color. Use the bounding box to reduce the working volume of the tool. When doing so, scroll through the slices of the dataset to verify that you are not excluding parts of the lungs. When you are satisfied with your selection, use the green button to validate the segmentation. Upon clicking on the Validate button, two things will happen. First, a new region of interest called Airways CT appears in the ROI tab. Then, the software automatically jumps to the next step of the workflow, called Edit ROI. The first editing tool we will use is the Isolate tool. When you open the tool, it prompts you to click on the structure you want to isolate. Click somewhere on the lungs in the 3D viewport. The selected structure becomes green. Validate and see the non-connected structures disappear. Now you want to separate the airways from the lungs. To do so, open the Split tool. The Split tool asks you to define a foreground and a background. The region corresponding to the foreground will be kept in the ROI, while the region defined as background will be deleted. View the coronal window in full screen by pressing the spacebar of your keyboard. And scroll through the slices until you reach the connection between the airways and the lungs. Now, change the diameter of the brush with this handle and roughly highlight the bronchi by left-clicking and dragging your mouse. Then, select the background option in the Split tool and highlight the lungs. When the selection is ready, validate it and let the algorithm do its magic. If the airways are properly separated from the lungs, use the red cross to close the tool. Note that if you would still like to edit your ROI, other tools can be used. Your region of interest is now well defined and ready to be converted into a 3D model. To create a 3D model from the ROI you made, click on the Add Part button of the workflow toolbar. Since the region of interest is made out of the air volume present in the airways, we want to create a hollow part with walls around the air volume. To do so, use the Hollow Part tool. Define a wall thickness of 1.5 mm. The hollowing direction should be set as outwards, and you can set it to low smoothing. Validate it and wait for the software to calculate the part. Once that has finalized, you will see that the ROI tab closed while the Parse tab opened. The software also automatically jumped from the Create Part step to the Edit Part step of the workflow. To check whether the model accurately represents the patient's anatomy, scroll through the slices in the 2D views and look at the contours of the newly created 3D model. Then, use the Cut tool to open the extremities of the model. Within the tool, select the Remove Inner feature. In the 3D view, click multiple times around the top extremity of the Airways, making sure you finish on the first point you created. Click the green button to perform the cut. Now repeat the operation to open the other extremities. When all extremities are opened, click on the red cross to exit the tool. As a last step of the editing process, we will use the Isolate tool to remove parts that are not connected to your Airways model. Click on the Airways and validate them with the green button. Rename the newly created part to Airways by clicking on the part name in the Parts tab. The part editing process is now complete. The last step of the workflow is the preparation of the model for 3D printing. Click on the Prepare Print button of the workflow toolbar. In this step of the process, you can add a label on your 3D part for traceability purposes. Use the Label tool to do so. First, select the method that you want to use, inward or outward. Then, define the text of the label in the text box. After defining the height of the label, place your mouse in the 3D viewport. Using the mouse, rotate with the right-hand button and pan the 3D model with the middle mouse button. Choose the place where you want to place the label on the part. When it is placed properly, left-click to apply the label. The label will now appear in 3D as part of the 3D model. The very last step before exporting the model is preparing it to ensure a successful print. Open the Repair tool and wait for the software to analyze the part. The Diagnose box says Ready for printing. You can now close the tool. Your model is ready for printing, and you can now export it as an STL file. I hope this video tutorial was useful, and in case you have questions, please contact us using the contact details mentioned on the screen.